Today we are going to look at organic chemistry. Specifically, we are starting with the functional group, and then we'll follow it with the naming of organic compounds. So, what is a functional group? A functional group is an atom or group of atoms that determines the chemical properties of a particular compound. So the functional group is what determines how the nature of the chemical properties of a particular organic compound will be. Like generally we have different families of organic compound, and what make one organic compound differ from one another family is the functional group. Like for example, as I said, a functional group is an atom or group of atoms that determine the chemical properties of a compound or an organic compound. So like for example, now let's take example with alkene. Alkene. Alkene is a compound or is a family of organic compounds that have a functional group or a single bond. It means that in alkene, all the carbon that are found in alkene, they have single bond. And that single bond that are found in alkene is the functional group of the alkene. And it's because of that single bonds that are found across all the carbon in the alkene, that is why they undergo some specific types of a chemical reaction. Like for example, in alkene, we just give example, we use generally alkene, they have a formula of CnH2n plus 2. So let's say we have n is equal to 4. So it means that we have C4H2 times 4 plus 2. So therefore now we have C4H2 times 2, we have 4, then plus 2, we have 8. So if we are to draw the structure of this, of course this is 4. So any organic compound that have 4 carbon is started, or the name started with bute. But because it is alkene, so that is why it's going to be butane. So we have butane. So if we are to draw the structure of this butane, we have two ways of writing the structure of this butane. It can be something like this: 1, 1, 1. So we have hydrogen here, another hydrogen here. So now here 2 times 2 is 8, 8 times 2, so here is 10. It's not 8. So here we have another hydrogen here, we also have another hydrogen. So therefore we can clearly see that in this compound butane, all the carbon, they have single bond. So single bond is the functional group of alkene. So the functional group of alkene is a single bond. So that is why even from the basic classification of organic chemistry, we know that compounds are classified into saturated and unsaturated. So since all alkenes they have single bond, it means that they are saturated hydrocarbon. It means that they are completely filled with the enough atoms. They are completely filled with enough hydrogen atoms. It means that they don't need any additional atoms to be added. And that is why alkene, it cannot undergo addition reaction because it is saturated. It can only undergo substitution reaction. It can only undergo substitution reaction because it is completely filled with an atom already. It's completely filled with hydrogen atoms. So that is why it can only undergo substitution reaction and combustion reaction. So with this, ladies and gentlemen, you understand that when we say a functional group, the functional group is what actually determines the chemical properties of a particular group of organic compound. Like for example here, as we said, alkenes, they have all single bond. So as a result of that, they are saturated and they don't need any additional atoms to be added in them. Rather, they can only undergo either substitution reaction, that is to remove one of the hydrogen and replace it with any other atoms, especially the atoms that are higher in terms of electronegativity than the hydrogen. So that is alkane. So alkane, we have this. So we also have another way that we can draw the structure of this methane. I think if you can do something like this, this is also methane. This is methane. So here indicates, here we have a carbon, here indicates it's a carbon, here is also carbon, here is also a carbon, and here is also a carbon. And since there is no any point where we indicate a double bond or any other functional group, it indicates that this is actually a butane. So this is structure, this is the skeletal structure of butane. So now the next thing is the next thing that we are going to look at under functional group is alkene. Alkene. The alkene also have a functional group. So the alkene have a functional group, and in the case of alkene, the functional group is they have a double bond. They have a double bond. So at least in alkene, we'll find that at least one or two carbon. The particular alkene, they have at least one or two double bond. At least one double bond or two double bond. So alkenes, they are always recognized based on the presence of double bond. And of course, whenever you have a double bond, that means that the compound is unsaturated. The compound is unsaturated. So, and of course, remember that alkene has this formula. So in alkenes, like for example, you can have something like this. So you can have a double bond. So this double bond is an indication that the alkene is having some deficiency of hydrogen atoms. So this double bond indicates that there is a deficiency of two hydrogen atoms. So that is why it can undergo addition reaction. It can undergo additional reaction because it is deficient, so it needs more other atoms. So therefore, because of this double bond, alkene can undergo addition. It can undergo addition reaction because of the presence of the double bond. And of course, we have what you call alkyne. Alkyne also have its one functional group. So in the case of alkyne, they also have triple bond. So it means that the functional group for alkane is single bond. So across all the carbon in alkane, they have single bond. But for the alkene, they have at least one double bond. And for the alkyne, they at least also have another double bond. They have at least one or two triple bond. So it is also have deficiency of some atoms, and that is the reason why it can also undergo additional reaction, but not substitution. So they cannot undergo substitution reaction because they are not sufficient. They do not have sufficient atoms. It's only the family that have sufficient atoms that can undergo substitution reaction. So then the next thing in the functional group, we also have a functional group of carbonyl compounds. A functional group of carbonyl compounds. So we have carbonyl compounds. Carbonyl compounds also have their own functional group. Like for example, when we say carbonyl compound, what does that mean? A carbonyl compound are compounds that have carbon to oxygen double bond in them. Carbon to oxygen double bond in them. Like for example, we can have, let's say, RCO or H. This is alkanoic. This is alkanoic. This is alkanoic acids. So alkanoic acids is one of the examples of carbonyl compound. And also this is R group, that is alkyl group. And we know that alkyl group generally have their formula. Alkyl group have their own general molecular. So the formula for alkyl group R, alkyl group is CnH2n plus 1. So that is why here for the alkyl, sorry, for the alkanoic acid, you can have something like this: CnH2n plus 1, then COOH. So if we have our N here to be 3, so it means that we have C2 times 3, 6 plus 1, so we have H7COOH. So you see in this compound we have 3 carbon. We have 3 carbon here and we have also 1 carbon here, so making a total of 4 carbon. So since it is alkanoic acid, so it's going to, if you are going to name this, it's going to be butanoic acid. It's going to be butanoic acid. And why do we call it carbonyl compound? It is because in alkanoic acid we also have carbon to oxygen double bond. They also have carbon to oxygen double bonds. Like for example, for this one, this is how it looks like. So for alkanoic acid, this is how they look like. They have carbon to oxygen double bond. They have carbon to oxygen double bond. So remember, in the case of like for example, if you are coming for naming, so it means that if you see any compound with COOH like this at the end, the name to naming it is going to end up with noic acids. It's going to end with noic acid. Like for example, here there are 4 carbon. So from the alkane, any compound that have 4 carbon is called butane from alkane. So it means that this is buta from the word butane. So but this is alkanoic acid. So we have butanoic acid. This one is now butanoic acids. So the COO here is also a functional group. So because this one is an acid, so it can also go on the specific type of reaction, and it's because of this functional group of COO. That is why alkanoic acid can undergo esterification reaction. Esterification reaction, and it's because of the presence of this functional group COO. So as I said, the functional group is what actually determines the chemical and the physical properties of an organic compound. Then another examples of functional group, we have alkanal, we have alkanal. So alkanal, it has a functional group of RCHO. So the functional group is CHO. So generally alkanal group or it has also another name. You can either call it alkanal or aldehydes. You can name it either alkanal or aldehydes. So in the case of alkanal, it is also another example of carbonyl compound. So it has carbon to oxygen double bond. So therefore now any compound that have CHO functional group, then the name is going to end with nal. Like for example, this is the alkyl group. Remember, alkyl group anywhere maintain the same formula. So therefore now, if we now have, let's say, if our N here is equal to 2, so it means that we have we take this, or let's say we have CnH2n plus 1, then we have CHO. So if we now consider our N here to be 2, if we consider N to be equals to 2, so we're now going to have C2H2 times 2, 4 plus 1, so we have H5, then CHO. So in this case, because of the presence of this CHO, so this is alkanal, so the name is going to end as propanal because we have 3 carbon. So ladies and gentlemen, apart from the alkanal, we also have another functional group, OH. OH is also a functional group, but for alkanol. It's another functional group for alkanol. So for the alkanol, they also have their R site, the R group, which is alkyl group. So therefore, if you want to actually get the families of alkanol, what you are going to do, you maintain the same alkyl group, which is CnH2n plus 1 OH. So if N is equal to 4, so we now have C4, H 2 times 4, 8, then we have 9 OH. So since it is non-alkanol, so this is going to be butanol. Butanol. And of course, because of the presence of this OH group, it can also undergo specific types of reaction. So ladies and gentlemen, what you need to understand is that in functional group, it's actually a group of atoms, or it can be an atom or group of atoms that determine, it might not always be atoms or group of atoms. It can be atoms, it can be group of atoms, it can be a bond that determine the chemical and the physical properties of a compound. So that is what they call functional group. Is an atom or group of atoms that determine the physical and the chemical properties of a compound. So it can be atoms, a bond, or group of atoms that determine the chemical properties of the compound. And we have so many of them. In fact, we even have the minor group. We have amide, NH2. Is also another functional group. R and H2. The NH2 here is also a functional group. And also another example, we have thiol. SH. Thiol is also another functional group. And another examples of functional group, we have also RCOR. So this is alkanone. This is alkanone. So all these are under the functional group. So the most important thing that you need to understand is that in functional group, it's an atom or group of atoms that determine the function, that determine the chemical properties of a compound. So this is actually for the functional group, and in the next video we are going to look at the naming of organic compounds.